Today's workshop build along is NPCs on the move. We're using NavMesh waypoints, and we'll also set up some randomly generated movement. And we're also going to be applying this to the avatar NPCs, and if we have time, to the player as well. Our agenda, I'm going to show you a demo of kind of what we're going to do, and then we're going to jump right into the build along. And then after that, we'll have Q&A. And here is the demo video. There's no audio, but basically we're going to set up, we're going to have, so we have a skeleton NPC, and then I have Bob, which is just an avatar NPC I created. They're going to follow a waypoint system. And then once they get done with that waypoint system, they start walking to random locations on the NavMesh. Now, the skeleton uses the NavMesh, whereas Bob does not. It just grab a random position in that area and have them move to that. And then that is pretty much it for the demo. Now we're going to move over to the build along. So this is going to be, we're going to use the engine. This world, I already have all the scripts, and I just got the new navigation bar today. So I might be a little confused with where things are supposed to be. I tried playing with it a little bit today, but we'll get through it. So the important things that we need, we don't need Bob right now. So I'm just going to move him. Where's the move tool? There it is. I'm going to move him down there for now. The only thing that we want to worry about is getting our skeleton to move along the NavMesh. So there's some things that we have to set up first. So one is pulling out the NPC. So in order to find them under the asset library, we want to make sure we're looking at Meta Horizon as the creator, and then go to NPCs on the bottom here. So there, you don't have to use a skeleton if you're if you're building along with me. There's a whole bunch of other ones you can use. I know for sure that these old ones work. I did not try it with these three or this one. I think these two are new. The other ones are been around for a while. So they work on those. And we're going to go into our systems, and we're going to go look at navigation. So the first thing that we want is we want to create a new navigation profile. So we'll hit this plus sign, which gives us this create agent profile screen where we can give it a name, description, and then set the agent's height, radius. So how tall is the agent? How wide is the agent? What slope? Like if you would put in a degree, so like 45 degrees. So if the degree is larger than that, they won't be able to move along that slope. They'll have to find a different way around or not be able to reach that height. By agent, so an agent is a component that's attached to the NPC. It's actually a Unity thing that I think is brought over with the UAB. So it's a NavMesh agent component that's attached to the entity or the object. And those things have these parameters that allows us to so the height allows us to determine if they can walk through. So like there's a tunnel, if it's too high, they won't be able to walk through it. Or if the tunnel is too low. Agent radius, how wide. So if you have like a narrow path, then they won't be able to traverse that section if the radius is too large. And then slope is for walking up like a ramp, and then step is for like stairs. So you just put in the variables that you want, and that allows the pathfinding system to determine how they're going to get to that position. So I have the skeleton one already made up. So I have it called skeleton. So I just gave it a description of skeleton NavMesh, agent height 2 meters, radius is 1 meter. It's pretty big, but it's fine. Agent slope, it's pretty standard for 45 degrees. And then the step radius, I just have as 0.33. There's no steps or slopes, so these really don't matter. So you just hit save. And then we have our NavMesh profile. But before we can bake it, we do need to bring in the navigation volume gizmo. So we'll go to build, go to So we would just pull in the navigation volume like so, and we already have one here, so I'm just going to use this one. And on the navigation volume, we can set it to be inclusion or exclusion. So what inclusion means is it's included into the pathfinding. And if it's set to exclusion, like if I didn't want them to walk in this corner, I could pull in another one. It's actually, just let me demonstrate that quick. Let's see what I'm doing here. We'll just make this a little bit bigger. And then I can set this to exclusion. And then when I bake my NavMesh, set the navigation profile to the one we just created. And then when we go back into navigation and bake, this portion will not be included, so they won't be able to pass through that. So that's what the exclusion is. And then the pathfinding will have to find a path around that. So if you have like trees or if you have like a big rock in the middle, you can add the exclusion, though a lot of items do have the ability to remove from baking, that it will bake around that. So now that we have our navigation volume set up, we do want to set up our skeleton. If you just pull it in, a lot of the stuff will be fine, except for we do want to make sure navigation locomotion is set as enabled. And we want our navigation profile to be the one that you created. So in this case, it's going to be skeleton. All this is default, except for I think I adjusted the speed. So if you want it to be faster or slower, this is how you would adjust that. And then if you want them to turn faster or slower, this is where you would adjust that. Stopping distance is how far away from the actual destination do you want them to start stopping. I have it set to 0. And then acceleration is how fast will they get to starting at 0 speed to their max speed. So how fast that is in meters per second squared, and then deceleration, the same thing, but slow it down. If you don't want them to move, you can set them as immobile. And then I have the alignment mode so that they're facing in their whatever velocity is. So that way, if there is a lot of turns, it'll just always face in the direction that they're moving. But you can set it to whatever the next waypoint is. That way, they'll just look at the next destination. And even if they're moving in a different direction, they're still always going to look at that destination. You can set it to the final waypoint, or you can set it to destination. I always have it set to physical surface snapping because I want them to snap to the surface. There might be some might be some cases where you don't want to use that. Maybe it's like a floating robot or something. You don't want it to snap to the surface. And then the required forward alignment set to 360 degrees. That's the default. And then I'm going to remove my script and we're going to remake that. So we're going to attach a script. It's a new script, and I'll just call this. Oh, it's skeleton. The original script is called skeleton controller. Let's call it S controller. We're going to have some naming convention issues. Wait for that to create, and I will open it up. All right, so we're going to edit our script. It's going to bring us into our IDE. I use Visual Studio Community. A lot of you probably use Visual Studio Code, so whichever IDE you use, it's fine. This is just the one I'm more comfortable with. First off, I don't like importing everything. You can if you want, that's fine. Just if you're going to do it this way, you do have to remove the HCs and import everything manually. Just fine. We're going to have some props definitions, so we're going to have to import prop types, and we're going to be adjusting. We're going to have an array of waypoints, so we're going to need to use vector3. So we'll just import those quick, get it out of the way. And then for our props definition, I'm just going to put in some waypoints here. Basically, they're just going to be vector 3s that we can set in the inspector or properties panel. So call it waypoint 1. Me type prop types as vectors. What's happening here? Oh, I forgot my colon prop types dot vector 3. Default will be a 0 dot vector 3. We're just going to do this for 4 of them. I'm just going to copy and paste and then change the number here. So 2, 3, and 4. And we're going to need a array for these. So I'm just going to create a private variable called waypoints. It's going to be an empty vector 3 or empty array of vector 3. And then in the start, we're going to, so it's going to be if this dot props dot waypoint 1. So if that exists, we will then this waypoint dot push, and then we're going to do that for all 4 of those. And it looks like AI is helping me out here. Awesome. So now we have an array of our waypoints, but we need to gain access to our NavMesh agent on our UAV, on our skeleton. So we do need to import a couple things from the NavMesh API. So we're going to import NavMesh agent, not from navigation. It's from NavMesh. And we're going to also import the iNavMesh from NavMesh. We want to cache our agents, so we're going to create another private variable here, private agent of NavMesh agent, and we're going to set that as defined, and then we're going to do the same thing with our NavMesh. So private NavMesh of type iNavMesh or undefined. And I also want to cache my destination so I don't have to keep getting it later. So I'm just going to do that quick destination. And that is going to be of type vector 3 or null. And we're just going to set it to null for now. And since we're going to be cycling through our waypoints, we want to have a waypoint index to reference it. So we're going to go private waypoint index, and we'll set that to 0, -1. So back in our start, there's a couple of things that we want to make sure that we cache. So we can do that down here. It'll be this dot agent will be this dot entity, since the script is going to be on the UAV. It'll be this dot entity dot as NavMesh agent. So we're going to be setting agent to this dot entity as NavMesh agent, so we can use that throughout and not have to keep getting it every time. And then we're going to do the same thing with our mesh, but there's something we have to do it a little bit differently. And we're going to go const mesh equals wait. And since we're using the await keyword, we have to start into an async function. So we're going to go here and type async. That way we can use await. This dot agent dot get NavMesh. The reason I do it this way is because now I can make sure that we're actually getting these. So I'm going to do a quick logic check to make sure agent and mesh exist. So I'll go if not this dot agent. You could do them in the same one, but I like to have it print out a warning. So I'll go console.warning, and then, yeah, that's fine. NavMesh agent component not found on entity. And then we'll return. Because we need to have these, so we don't want nothing else running. And then we'll do the same thing with our mesh if that doesn't exist. So if that mesh, we will do console.warn, NavMesh not found, and then we'll return. Then we can do this dot NavMesh equals mesh. Now we're going to create a new function. We're going to call it getNextPoint. We also want to make sure that we have waypoints. So if this dot waypoints dot length is equal to 0, so if there is none, we will do a console.warn saying there's no waypoints defined, and then we'll return. We could do this up where we do the checks, but this is a little bit quicker. And then we'll just go this dot getNextPoint. So just so we can go over that quick, we have a props definition, one for each waypoint, and then we are caching. We have a variable for our agent, our NavMesh, our destination, our waypoints, and we have a waypoint index. And in start, we are setting our waypoint array. We're pushing the waypoints in there if they exist. We are caching our agent and our NavMesh. We're making sure they exist. And then we're making sure we actually have waypoints. And if we do, we will try to get the next point. And I'm going to do some checks in here. So we want to make sure that our NavMesh and our agent exist again. And the reason we do this, so we don't have to add that exclamation mark at the end of when we use this agent. We want to make sure they exist beforehand, so we don't have to do it that way. It's not good to do it that way or get used to doing it that way. We'll just return if it doesn't exist. We don't need to post a console.warn. Console links we're already checking. We'll just do it again with this agent as well. And my AI likes adding rounded brackets to the end of everything. It's fun. And we're going to update our waypoint index first. So it'd be this dot waypoint index, and we're going to increase it by 1, but we don't want it to go over our length. So we're going to use modulus, and AI got to it again. So basically what it is we are going to increase the waypoint index by 1 every time this runs. And then we're going to use the modulus of that number and our length. So if our number is now equal to our length, it's going to return at 0. And then just keep going up until we get to that length again, and it'll go back down to 0. And we're going to set this destination to, we're going to take the waypoint array, and then we're going to take in the index that we just set. However, we don't want to just use that. We need to get the nearest point on the NavMesh. So it'll be this dot NavMesh dot get nearest point. And then we'll use the index of our waypoints. And I forgot an equal sign here. And it doesn't like something. And so I think it's because I forgot a comma here. Because we also have to give it the length. So like how far away do we want it to go? So if our destination is way off the grid, then we might want to do something else. But I'm going to do something small. Sure. So now we know what our destination is. So we can get our distance from where we currently are to where we want to go, where our destination is. So I'm going to go const distance. And that's going to equal this agent that I don't want it to post everything. Position, because it was wrong that time. That I can get. And then we're going to go dot distance so we can get our distance, and then it'll be this dot destination. Nope, too many D's there. Okay. Why aren't we doing this? I forgot a. Huh. It doesn't like that. Const distance. Just that agent, that position, that get the distance. I set it up right up here. So no, this could return null. So that's why we had to do it that way. And it has to be a number. We have to make sure it's not null, because it is possible that this will return a null value if there isn't a closest point with this value and this value. So we have to make sure that destination exists. So we're going to go if not destination, then we'll return. So now that we know that destination exists, we can get the distance between our current position and our destination. And then we're going to try to figure out the speed between, now we're going to try to get max speed of the actual avatar. So whatever the max speed is set to when we created the UAV, when we brought it in the properties panel. So we're going to get that. We're going to say const speed. That's going to be equal to this dot agent dot max speed dot get. All right. So now we have our speed variable, and I want to figure out our walk time. So how long is it going to take for the skeleton to get from where he's at to the next destination? So const walk time, and that is going to equal the distance. Oh, we want to put these in brackets. Distance divided by speed, and we're going to multiply that by 1,000 because when we do our set timeout, it needs to be in milliseconds. So that's why we multiply it by 1,000. So now we have our walk time. Now we can set our agent's destination. Well, this dot agent dot destination, and we're going to set it to this dot destination. And then I'm going to do a async timeout. So it'd be this dot async dot set timeout. Put in agent async dot set timeout. And then it'll be our walk time plus 250, because when we do our walk time, it's plus a little bit for the stopping distance. So he's going to try to stop. And if we don't add this, it looks like he stops and it's kind of slides. So that's why we add this right here to our walk time. And then I'm just going to this dot get next point. So what's going to happen here is when we get the next point, we make sure the NavMesh exists, we make sure the agent exists, and then we get the next waypoint index based on our current index plus 1 modulus the length. And then we get our distance by getting the NavMesh's nearest points using that variable and the distance from that. So if the destination exists, we get our distance, speed, and walk time, and then we set our agent destination, and then we just call that again based on its walk time and 250. So we're going to save that, and we go back in here. So now when we put these down here, I do need to click on our skeleton, and these are the variables that I had in there before. So the waypoints I have set up are 5 on the X, 5 on the Z, 5 on the X, -5 on the Z, -5, -5, -5, and 5. So now we have our NPC walking around its waypoints, but it doesn't have any animations yet. So we do want to set up some animation parameters. Now UAVs have these already built into it, so we can access those. So if we go back into our script, we can set that up. But we do need to get a reference to the asset bundle. So we do need to import for those. So it's going to be import, and we're just going to import asset. Actually, let me just set this part up. That way it can get better. Horizon, and that's Unity asset bundle, I think. Then we need to import the asset bundle reference, and then we need to import the asset bundle gizmo. We do need to cache our reference to that, so we're going to create a new variable. So it's going to be private asset ref, and then it's going to be of type asset bundle instance reference, or undefined. And then we do need to set that. So we're going to do it right here. It's going to be this dot asset reference, and then we'll just go this entity dot as asset bundle gizmo. So now we have a reference to that. Now we want to make sure that that actually exists. So we're just going to copy one of these over here. So it'll be if not this dot asset ref, we will console.warning that doesn't exist, and then return. So we do need that. Now we'll go down to getNextPoint, and we're going to add this check here. So if not this asset reference, return. And then right after we set the destination, we're going to set the animation parameter. So in order to do that, it'll be this dot asset reference, or asset ref dot set animation parameter. We're going to set the speed, so that's a float parameter. So we're going to float, and then we'll set speed. Oh, it's got to be a string, and it's capitalized, so speed like that. And we're just going to set it to the agent's max speed. So it'll be our speed variable here, speed. And so that'll set the animation speed. And then we're going to do the same thing, but we're going to have it, we're going to tell it that it's moving. So we'll go asset ref dot set animation boolean. And the name of the boolean is going to be and we're going to set that to true. Then we're going to copy that right after we get there. So when our timeout stops, and right before we call it again, we're going to tell it to stop. So we'll set speed to 0, and then we'll set moving to false. And you'll understand why we're doing this in the next step. And we're also going to copy this over here because I don't like adding question marks and stuff. And now when we go back in and play, now he's animating, is moving, and it looks like it, like the speed of that animation makes sense. That's why we adjust moving and speed. The next thing is I want to add an idle. So like once he gets there, he's going to stop because it looks weird when you get to a corner and then you just quickly go the other direction. So we're just going to add a quick animation for or a quick stop in that. And I am going to create a new props definition for this. So it'll be, we'll just call it idle time. It's going to be in milliseconds. Let's add MS on that. And it's prop types, and we can give it the default of 3000. So type number, okay? Make sure AI gave it the right thing there. And then the next thing we're going to do is all the way down under getNextPoint, where we're getting our walk time. We also want to set up our idle time. And all that is const dot, we'll call it idle time. I'll just set it to this dot props dot idle time. And now what we're going to do is we're going to create another timeout inside of this. So it'll be this. So right after we tell it to stop moving, it's going to be this async set timeout. And then we're going to have our getNextPoint inside that timeout, and we're going to put it past our idle time. So now when we play, make sure everything compiled. think that is all of them. Now, when he gets to this corner, he's going to wait for a couple seconds, and then he'll keep moving. And then the last thing I want to add is the random positioning. So instead of it just following a waypoint, it'll select a random position on the NavMesh and then move to that. So we'll go back to our script, and we're going to create a new prop type. And this is just going to be for the navigation volume, so we know the size. That'll be called navigation volume. That's going to be of, didn't get it right that time, type prop types dot entity. I'll just keep it that way. Then we'll add our comma, and then we're going to do another one for using waypoints. It's going to be a Boolean, so it'll be use waypoints to type Boolean, and we'll just set it to default to true for now. That way it just always does that. And we're going to create a entity variable to hold our actually, no, let's do a vector3. It's going to be our NavMesh scale. So NavMesh scale, so we know the width, and that's just going to be a type vector3. And we'll just set that to vector3.0. That way it's not a potentially null variable. And then we do need to check to make sure that our navigation volume exists. So we're going to go if not this dot props dot navigation volume. Into our warning, and then we'll return, and then we'll set this dot NavMesh scale. It'll be this props dot navigation volume dot scale dot get. So now we have the scale, and where we get our point, we're going to do a little different. So instead of just getting a point like this, we're going to require a Boolean. That way we know whether it's a random position or a waypoint position. So the random position, we're just going to go is random and require Boolean. And then we're going to do a check here. So it'll be if this dot props dot use waypoints. If that equals false, then we will pass get next waypoint, and we're going to say it's true because we want to use that. Alternatively, we could just pass in this like that. So actually, let's do that. It's probably a little bit simpler. And then instead of is random, we'll say use waypoints. A little bit simpler there. Looks like my spacing grew off a little bit. Well, maybe not. Now, since we want to get a random position, we do have to figure out our X and our Z. So up here, we're going to go if use waypoints. So if that's true, we're going to set our destination to that, what we did in the last time. Else, we want to get our X, Y, and Z. So const X. Is that right? Math.random minus 0.5 times the scale. Yeah, that is right. And our Y is not correct. Y should be 0. And then our Z, that is correct. And then destination is this dot get nearest point, new vector3, X, Y, and Z. Well, AI is really helping out today. So now we have our destination if it's a waypoint system, and we have our destination if it's a random system. Now we need to update our async function down here. And we're just going to do the same thing that we did up here. So I can just copy this and paste that here. So then after our walk time is done, it does its idle time. And then if it's a random system, it'll do it this way. If it's a waypoint system, it'll do it the other way. And just to showcase that, we will click on our skeleton and we will set this to not use the waypoints. And we do have to link our navigation volume. We'll paste that in there. And now you should walk to a random spot, wait a couple seconds, and then walk to another random spot. Now we do have a couple more seconds. I can just go over the NPC controller script real quick that's attached to our NPC friend, Bob, instead of actually building it out, because it will take more than 7 minutes to build out. So if you guys are okay with that, we can do that quick. And I will share these scripts as well. So instead of having to get the NavMesh and all that we have to do with our skeleton script, we're going to put in the X and Y or X and Z range for our NPC manually, instead of getting it from the navigation volume, because they don't require the navigation to move. You wouldn't have it. So we're just going to manually place it in there. And then we're going to adjust the move speed. So the big change here is, instead of getting the agent and the mesh, we do have to get the NPC and the NPC player. So we are importing from the Horizon NPC API. And a lot of this is the same as the other one. So we still have our waypoints, and we're still, doing the getNextPoint, but this one I'm just using true or false. So we could use waypoint like we did in the last one, but I didn't think about that until just now. So this is going to be a little bit different. So if let me see, I can put them side by side here. Let's do that. Might be a little bit easier for you guys to see it. We still got a couple minutes here. All right. So in our start, the only thing I'm doing different here is I'm getting the NPC and I'm making sure the NPC exists. And then I get the NPC player. And then I set the getNextPoint. Whereas with our skeleton, we had to get the NavMesh scale. We got the agent. We have the reference to that agent for the asset bundle, and we have to get the mesh. Up to that point, it's the same. Now we go into our next point here. There isn't a lot of checks. We just had to do the NPC check, but we're still getting our position. So the position is the NPC's position. We're doing the random position like we did before. We're just making sure position, the Y is the current position is Y, because you don't want it to start moving down and up, because we don't have a NavMesh to get a position on. So we do have to set the Y. And then we have, see here, this destination. So we are getting the destination like we were before. This is for not a random thing. And then we do move to position. So instead of setting the NavMesh's position, we use move to position. And this allows us to do it on the player as well, because the player has access to this. So this is how we set the position for an avatar NPC. And so you can see it working on a player, because the avatar script and the player script are basically the same. And then you can go in and it will actually control the player as well if you wanted to control player. I hope you guys learned something, and thanks for watching, and have a good one.